Okay, this is video 2 in the Mr. Siskin Quarantine series. We'll accomplish a couple of things today. We will look at how to deal with the transition metals, and a very quick review. We'll talk about those pesky parentheses. You saw my pool. I am outside in the yard. It's what I felt like. If the pool was warmer than 61 degrees, I might have got in there, but it is not. Today and for most of this week, we will still be dealing with only ionic compounds. So the charges are our guide. They tell us how things combine. Most of the questions I've gotten from you guys was when we hit polyatomics and those pesky parentheses confused you. So I've got one quick example here on the board to look at, and there are videos to go back and watch. But we're looking at aluminum chloride and aluminum chlorite. Notice the D, the T are the only things that are different. And remember, when we're dealing with polyatomics, if it ends in ITE or ATE, it's gonna be there, okay? So let's look at how we form the compounds. Most of y'all are great with this. You look at aluminum, you find it on your table of ions, it's 3+. You find chlorine, it's a -1. Need more minuses, so you write another one, -2, still need another, write another one. So we've got 3+ and 3-. So our formula is AlCl3. This is really no difference. Those of you that are struggling a bit with the parentheses, keep in mind this is simply a thing. ClO2 with a -1 charge is one thing, just like Cl is. We treat it that way. This is the anion. So we've got one ClO2 and it's got a -1, aluminum's +3. So we need another. So we write another. Now we're at -2, we need yet another, so we're at -3. So just like over here, where we needed one aluminum and 3 chloride ions, over here we need one aluminum and 3 chlorite ions. Now the only way we can show that there's 3 of these things is to use those parentheses. And that's the only time we use them. So right here with the parentheses around the chlorite, that tells us that there are 3 chlorite ions in one FU of that molecule. Okay? So there's our review. Now we're going to go step into the new stuff and look at how we deal with those transition metals. I'll change this board out as quick as I can. Hang on with me. Whew, okay. So the first and the easiest part is when we have the name written out and we've got to figure out the formula. Now what these Roman numerals, hopefully we know our Roman numerals now. That is 2, that is 3, that before that is 4 because V is 5. But you'll notice when you look here in the transition metals that some of these boxes are split. Like for iron, it's got Fe3+ and it's got Fe2+. And the reason you see that is these metals are multivalent. That means they have more than one possible valence state. They could exist as a +2 ion or a +3 ion. There's options. So if you just saw the name iron chloride, you wouldn't know which of those 2 formula to write. There has to be a way to tell you. So the Roman numerals come into play anytime you see a split box here. If you don't see a split box, don't put a Roman numeral. It'll be wrong because there aren't any choices. We're getting a little wind. I thought my board was going to go away. It did that earlier in a practice. Maybe not. But look for that split box. Now when you see the name, you'll know it's a split box because the Roman numerals are going to be there. So when you see this iron 2 chloride, that 2 tells you it's iron +2. So if you've got iron at +2 and chlorine at -1, you need 2 chlorines, FeCl2. Iron 3 chloride, that tells you it is iron 3. It has a +3 charge. When you write the formula, you need 3 chloride ions to balance it out. Scandium chloride, you've just got to find it on here. It's right here, and look, it says SC. You probably can't see this, but you have your element 21. SC3 is its only choice. So scandium forms a 3+ ion. That is it. So you've got SCCl3. Zinc chloride. Getting harder to read this, but zinc's over here. It is only 2+. So there's no Roman numeral in the name. And if you are writing in the name, don't give it to me. because it is always 2 plus, ZnCl2. And here we have manganese, parentheses, IV, Roman numeral 4, chloride. When I see manganese here, it's element number 25 right next to iron. It could be 2 plus or 4 plus. This tells me I have manganese 4, MgCl4. That's going from the name to the formula. When you go from the formula to the name, that's when you have to think. Let me write a couple of those down real quick. Okay, there we go. It took me a long time to come up with this set of examples, but now we have formulas, and we need to come up with the name. And this is what you've got to just simply get in the habit of doing now. When you see a formula, find the metal and see if there are choices for its charge, like iron is right here, element 26. It has choices. So you have to figure out what iron it is. You can't write the name. You have to figure out, is it iron 2 or iron 3? And you know, it's just like writing the formula in reverse. So you've got iron, and you don't know what charge it is. And you've got 2 chlorine ions, 2 chloride ions. They each have a -1 charge. So I've got 2 of these ions at a -1 charge. So that's my total charge is 2 minus. So this 1 iron ion has to balance that out. So it has to be +2 to balance it out. That means this is iron, parentheses, Roman numerals, chloride. Let's fix this just a little bit. I've got board creep going on. There we go. Now on this one, I've got iron, and it's paired with 3 chlorines. We'll get rid of this, make it. So I've got an iron, I don't know what it is. I've got 1, 2, 3 chlorine ions that are partnered with it in this formula unit. So my total negative is 1, 2, I've got a 3 negative total. The 1 iron has to balance that out. So it's going to be iron 3 chloride. Now I see this one, SCCl3. The first thing you do is find the metal. Oh, it only has 1 choice. I don't need a Roman numeral, I just write the name, scandium chloride. Crazy easy. I look at my next one, zinc, and I look over here. Here, element number 30, there's zinc. It is only 2 plus. I don't need a Roman numeral because there aren't options. So simply zinc chloride. MgCl4. That's wrong. I meant to write Mn. Was the other screen wrong because I did this in a hurry? Did I have manganese and put the symbol for magnesium? I hope you guys noticed then and were laughing at me. So MnCl4, because if you'd looked at Mg, you'd see it's only 2 plus, so what the heck was going on? No sense was there, teacher error. It might happen again before the year's out, hopefully not. So I find Mn, oh hey, look, Mn does have that split choices. There's 2 plus, there's 4 plus. I've got to figure it out. I've got 1 Mn ion, I don't know its charge, and I've got 4 of these chlorines. 1, 2, 3, 4, my total negative is -4. And that 1 manganese ion has to balance that, it must be +4. Manganese. 4, chloride. And yes, tomorrow, and maybe a little bit today, oh, it'll be tomorrow, you'll start playing with these with polyatomic ions and all that other good fun stuff. We'll keep going. Hope you're doing well. I'll keep answering your email questions. Hope you guys are fine. I can't wait to be back there.